Hey guys, welcome back to my channel, The Math Pad, and today we're going to talk about 3D shapes and how we can find the areas and volumes of 3D shapes. So if you look at the first question, we have a pyramid, which is a square-based pyramid, and it says the diagonal of the square meet at M, E is vertically above M, AB equals to BC, which equals to 12 centimeters, EM equals to 9 centimeters. You have to calculate the angle that the edge EC and the base ABC of the pyramid. So edge C edge and and that would be this one. So what we can do is we know that it's square base. That means each angle is a right angle over here. So keeping that in mind, we can apply Pythagoras to find AC. So AC square equals to AB square plus square. AC square equals to 12 square plus 12 square. Square 44 into it equals to 288. Then to find AC, we take the square root of 288. So square root of 288 is 16.97. Now that we have AC, we can find AM or MC in our case, because that's the side that we're by dividing it by 2. The reason why we're dividing it by 2 is because we know that M is the midpoint of AC. So MC is going to be exactly half of AC. That is 8.49. Now that we have this length, we can apply SOHCATOA to find the angle. So in our case, since we have the opposite, which is EM, and MC, which is the adjacent, we will apply tangent. Tangent theta equals to 9 over 8.49. Then we take tan inverse of this fraction. Now we just plug this in the calculator. 9 divided by 8.49, and then tan inverse of that, 46.67 degrees. That is your angle between the edge EC and base. Then if we move on to the next question, it says that we have to calculate the volume of a hemisphere, which has the radius of 3.2 centimeters. Now, unlike the circle, hemisphere is a 3D shape. And the formula for the volume of a hemisphere is going to be half that of the sphere. So we do 203 pi r cubed. That is the formula. And since there's just one unknown, which is radius, substitute that value. Then just plug in the calculator to find the exact value. So 3.2 cubed times pi times 2 divided by 3 is 8.6 centimeter cubed. Then if we go to the next question, we have another hemisphere, and they've given us the diameter of the hemisphere. They want us to find. So firstly, we find the radius, which is half of the diameter. So 5 divided by 2 2.5 centimeters is the radius. Now we plug it in the formula. Goes 2 over 3 pi r cubed, 2 over 3 pi times 2.5 cubed. Plug this in the calculator. 2 pi times 2.5 cubed divided by 3. That's 32.7 centimeter cubed. In question 4, we have an isosceles triangle and AB is equal to C, and angle B is given as 44. So asking us to find angle AC this time. So as we know, sum of angles for a triangle equals 180. So we will do 180 equals to, let's call this x, call this x, x plus x plus 44. The reason why I wrote two x's over here is because it's an isosceles triangle. In an isosceles triangle, the lengths, two of the lengths are equal, and so are their corresponding angles. Hence, we're using the same variable. So 180 minus 44 is 2x. Then we do 180 minus 44, which gives us 136. Then we divide 136 by 2, which gives us 68. That is our angle for AC. In the next part, they're asking us, we have a regular polygon which has an exterior angle of 40 degrees. Work out the number of sides of the polygon. So for this, we have a formula. Exterior angle equals to 360 divided by sides, which means we will do 40 degrees for n equals to 9. So this polygon has 9 sides. Then in question 5, once again, they're asking to calculate the volume of the sphere. Same formula, 2 over 3 pi r cubed. They've identified the radius, 5. So base r is 5. Plug it in the calculator. So 2 pi times 5 cubed divided by 3. That is 261.8 centimeters. Next question is about similar shapes. So we have two similar shapes, which are jugs in this case, and they have given us the height and the length of the base. We want us to calculate the value of x. So when we have similar shapes like the ratios, when I say the ratio, what I mean is that if I write 15 over 25, 15 over 25 would be the same as 7.2 over x. So we're putting the ratio of height equal to the ratio of the base. And you have to make sure that if you're putting, for example, the height of this smaller jug in the numerator, then the base of the smaller jug will also be in the numerator in the other fraction. It's very important. So once we've made our fraction and equation, cross multiply, make x subject, and then object. So 7.2 times 25 divided by 15 is 12. X equals to 12 centimeters. Then we have another set of similar shapes, and in this case we have two classes. and they have given us the height of the class, of bigger class, but we don't have the height of the small class. However, they have identified the volumes. So when you're talking about volumes in similar shapes, h1 over h2 whole cube would equal to v1 over. So v1 is the formula of like, not the formula, v1 is basically the volume of like, let's say this smaller class. Volume 1 and height would be h1. For the big class, volume is v2 and height is h2. So this is how we assign the values. And then what we do is we substitute them. So I'm going to say that y over 16 whole cube equals to 192 over 75. So we take the cube root of like the fraction on the right hand side. And times that by. So we plug this in the calculator. Divided by 75 raised to the power of 3 times that by 16. That's 12.8 centimeters. That's the value of y. Then question 7 is asking us to find the volume of the solid. So as you can see, it's like composite shape. In this composite shape, first half of the shape is cone, and the second half is the hemisphere. So volume of the cone is equal to 1 over 3 pi r square h, which is also given the question, and volume of the hemisphere, which we've done in the previous questions as well, is 2 over 3 pi r cubed. So as you can see, they have given us the height, and the height, okay, another very important point, the height always has to be the perpendicular height when we're finding the volume of the cone. It's not the slant height. When I say the slant height, this is your slant height. Yeah. This is your slant. You'll be using the slant height when you try to find the surface area of the cone, but for the volume, we need the perpendicular. So back to the question, we substitute the values 1 over 3 pi 4 square because radius is 4 and height is 9. So that is going to give us 4 square times 9 times pi divided by 3. That's 150.79 centimeter cube. And for the hemisphere, 2 over 3 pi times 4 cube. That's 134.04 centimeters. So total volume is obviously going to be the sum of these two values. So 150.79 plus 134.04 284.83 centimeter cube. It says give your answer to the nearest cubic centimeter, so that's going to be 285 centimeters. That is the final answer. Then if we move on to the next question, we have a square pyramid again, and they're asking us to find the surface area in this case. So what we're going to do is, let's begin with the base. Area, base, just square base. So we do 20 times 20, 400 centimeters square. Then find the area of these triangular faces. So for that, we need to find the length B, B, and this. Okay. So first, we begin with finding AC. So AC square equals to AB square plus square. AC is going to square root of 20 square plus 20 square. 800. So if we can plug this calculator, so that's going to be 28.28 centimeters. Then MC is going to be 28.28. 14.14. Now, 14.14 is not just MP, it's AM, it's DM, and it's MB as well. All of these equal to 14.14. Okay, so 14.14, 14.14. Okay, next step is to find the length of PB. So for the length of PB, we'll apply Pythagoras again. So PB is going to be square root of 8 square plus 14.4 square. Directly plug this in the calculator. So 4 square plus 64, and then we take the square root of that. $16.25. That's so now what we'll do is we will find the perpendicular height of the triangular face. So for that, we have hypotenuse. We know that the base is going to be 10 if we, split it into two halves. So for the height, we're going to do PB, and let's call this N. PB square equals to PN square plus BN square. So what we're trying to find is PN right now. So that means PB square was 16.25 square. PN square is our unknown, and BN square is 10 square. So bring everything on the other side. 10 square square root. So 16.25 square plus the minus 100. And then we take the square root of that. So square root of 164.4625. 12.81 centimeters. Okay, So now we find the area of the triangular faces. Area of triangular faces. That's going to be 4 times, because there are 4 faces, 1 over 2. Perpendicular height is 12.81 and base is 20. So 12.81 times 20 times 2, 512.4 centimeters square. Total surface area is going to be 400 plus 512 equals to 912.4 centimeters. Yeah, it's like sort of a lengthy calculation, but you have to find all of the missing lengths first in order for us to be able to find the area of the triangle. Then if you move on to the next one, question 9 is saying that the base of the rectangular tank is 1.2 meters by 0.9 meters. So if I roughly draw a rectangular tank, let's say the tank. Base is 1.2 by 0. And the water in the tank is 53 centimeters. So this length is 5.53, sorry. Now these are in meters and this is in centimeters. So first we convert 53 centimeters into meters. We know 1 meter is 100 centimeters. So that means 1 centimeters. So 53 centimeters is 0.553. 0.53. So volume of a cuboid, just the cuboid, is length times width times the height. So we multiply 0.53, 0.92, and that is equal to 0.57. For centimeters. No, sorry. Now we have to get the answer in meters. 1 meter cube is equal to 1,000 meters. So we do 0.574 times 1,000, which is 57 point. That is your question. Then in question number 10, they want us to find the volume of this complex shape again. So the top half is a cylinder and the bottom half is a sphere, as told in question 12. If identify the radius, then identify the height as well. So volume of a cylinder is pi r squared h. R is 5, height is 8. So plug the value in the calculator. Going to be 5 times 5 times 8 times 5. That is 628.3 volume of hemisphere. So we use the same formula that we've been using. 2 or 3 pi r cubed. 2 or 3 pi and pi cubed. And that equals to 261.8 centimeters. Now, total volume will obviously sum of these two. 628.3 plus 261.8, and that equals 890.1 centimeter cube. That is your answer. If you have any questions or confusions about any of these, just let me know in the comments below and I'll help you out.